This is part of the lecture for multivariable calculus, and in this video I'm gonna talk about cross product. There are two ways to multiply two vectors together. One of them would be dot product, and the answer for the dot product would be a number. The other one would be cross product, and the answer for the cross product would be a vector. So what is a cross product? Cross product, or sometimes we call it vector product. If we have a vector A with components A1, A2, A3, and B with the components B1, B2, and B3, then the cross product of A cross B would be a determinant. On the first row of the determinant of the matrix, we are gonna put the vector I, J, and then K. On the second row, I'm gonna put the vector A, A1, A2, and A3, and then B1, B2, and B3 on the third row. The answer for this would be what? Would be I, okay? And then I'm gonna multiply the vector I. I'm gonna remove the row and column containing I. I'm gonna left with this matrix, which is A2, A3, B2, B3. And then I have negative J, okay? And then I'm gonna remove the row and column containing J. I left with A1, A3, B1, B3, and then it would be plus K, and when I remove the row and column containing K, I left with this matrix in here. A1, A2, B1, B2. Okay, so what are these determinants? Let me give you a recall of the determinant. Determinant of a vector A with the components 1, 2, and the vector B in just 2D, okay? 3 and 4, the vector 3 and 4 is this. 1, 2, I'm gonna put 1, 2 on the first row, and then 3, 4 on the second row, and then the determinant would be 1 times 4, okay, this, minus 2 times 3, okay, so this minus that. So this is 4 minus 6, which is negative 2, okay? As a note, this is determinant in a two-dimensional vector space. And now in 3D, as a note, in 3D, determinant of a matrix 3 by 3, this matrix. Just assume that I have X, Y, Z on the first row, then I have A1, A2, A3, and then B1, B2, B3. Okay, so it would be X, determinant of the minor or the matrix that is left by removing the row and column containing X. I left with A2, A3, B2, B3. Okay, and this is exactly like this matrix. It would be A2, B3, 2B3 minus A3, B2. Okay, and then I have a negative sign for X, for Y, negative Y. Then I'm gonna remove the row and column containing Y. I left with A1, A3, A1, A3, B1, B3. So this is again would be a1b3 minus a3b1. And then the last one would be plus z. Remove the row and column containing z. a1, a2, b1, b2. Okay, so this one would be a1, b2 minus a2, b1. Okay, and this is the same idea in here. So I have a2b3 minus a3b2. Okay, great. Now this is definition of the dot product. What is the geometrical meaning of that? So I'm gonna say that geometrically, when I have a1 cross b1, okay, the length of it, as you see, let me bring it one more time. The cross product is a vector because it has I, j, and k. Okay, so it's a vector, and these are just numbers. Okay, so the cross product is a vector. So this vector has a length. The length of this vector is the length of a, the length of b, and then sine theta, and theta is the angle between a and b. Okay, and notice that this is just a number. This is a number. Length of vectors are number, and sine theta is just the number. Let me give you just a small recall of the dot product. So a dot b is just a number, so it doesn't have a length. It's a number, so dot product was length of a, length of b, and then cosine theta. That's the difference between cross and the dot product. So one more time, vector a cross b, since it is a vector, it has two characteristics. One of them is its length. So the length of it, the length of a cross b is a cross b, and it was a, b, and then sine theta, which is what? If I have a vector b in here, if I have a vector a in here, okay, then this theta is the angle between these two. If you notice that, okay, this is a parallelogram. This is the copy of b, this is the copy of a. So I can make a parallelogram, and in this parallelogram the base is a, so the base is the length of a, and the height of this parallelogram, considering this right triangle in here, it's the length of b, the hypotenuse, times sine theta. Sine theta, that's the height. So the height is that. Therefore, the length of the cross product would be the area of the parallelogram. Okay, very good. How about its direction? So the direction of a cross b is what? The direction of a cross b, so a cross b was a vector, so the direction of that is important, and the direction is perpendicular to the plane of the parallelogram of A and B, with direction of right hand rule. Right hand rule. Okay, what do I mean by the right hand rule? I mean this. Okay, what is that? I mean, we're gonna put your right hand in the direction of A, the direction of A. Then we're gonna curl fingers towards B, then your thumb points in direction of A cross B. Okay, so assume that I have a plane that contains A and then B. So how can I figure out the direction of that? I'm gonna put my fingers in the direction of A, then I'm gonna curl my finger in the direction of B, and then my thumb shows the direction of A cross B. So in that case, this would be A cross B. As you notice that this vector is out of the plane and it's actually perpendicular to that plane. Okay, let's go over some properties of A cross B. So properties, the first property is that we have only in A cross B in three-dimensional spaces. Why? It's just because the cross product is out of the plane of A and B. That's why we need three-dimensional spaces for that. The second property is that it's not commutative. A cross B, it's not equal to B cross A. It's actually negative of that. Why? It's just because of the shape. So it's a plane that has A and B, okay, and if I want to have A cross B, it would be I put my fingers across A and then curl it in the direction of B, then A cross B would be here and it going up, but B cross A, putting fingers across B and then curl them in the direction of A, then B minus A would be, B cross A would be actually the negative of that in the opposite direction. Then another property is that A cross A, 3A cross A is equal to 0. Why? It's just because sine of the angle between A and A is 0, so sine of that would be 0. And number 4 that I'm showing this by just the number A, 5A plus 7B cross C, okay, it's just distribution law. It would be 5A cross C plus 7B cross C. Okay, so we have distribution line here, but I cannot change that. And these were properties. So let's go over some applications of cross products. First, I can use them to find area of triangles. Finding area of triangles in a space. How? It's just because the area of a triangle is actually half of the area of of parallelogram. This is half of that, and the area here would be the length of A cross B. If this is A, this is B. Okay, so that's why we can use the cross product to find the area of triangles. Then we can find a vector that is perpendicular. So I say finding a vector perpendicular to both A and B. Can find vectors that is perpendicular to both. And number 3 is checking parallel vectors. Okay, so if two vectors are parallel, then their cross product would be 0. So I can say that A is parallel to B if and only if their cross product is 0, meaning that the 0 vector. Okay, so on the next video we're gonna talk about some examples for all of these properties and these applications.